So now, sometimes you'll be dealing with a big data set, and you'll say, like, well, I don't really care about these columns. I just want to concern myself with only certain columns for a while, but I still want to operate on a data frame. So if I just did this, right, I get back a series. But if I want to get back a full data frame, oops. I basically tell it, the idea is, I will index by the list of columns that you give me, and you'll get back a data frame out of there. So here I have a list of size 1. So now we're label-based indexing into the DF grades data frame, going only for January. And the result that you get back is this entire row, right? So this is where it gets a little bit weird. Now we have, so the way to think about this is a slice of the data this way, but what is the type of that DF row? It's just this one-dimensional. It's a one-row data frame.
What's the difference can you convert between a one-row data frame and a series?
Yeah, if you do this, should be able to, that failed massively. Well, the problem is we have too much information. Like, we still have this, if you wanted to have your series be, so basically there are 3 numbers here, right? There's a label associated with this column, a label associated with this column, a label associated with this column. So you could, in theory, sort of flip that, right, and make that into a series. But we have an additional, this index here wouldn't have anywhere to go. So if I wanted to make this into a series, I would probably do something like, so this is a nice feature of the notebook is, actually, people haven't seen that before. Whenever you have like some kind of object and you want to get some help on it, you can put a question mark after it and then execute that cell, and then it will pop open. So what I would do is I would want to make the index the columns of this data frame, and then I would just use the values of that row. So I do something like this. I do like DF row, Jan. Oh. So the question is, are we going to cover matrix operations? Typically, if you had a real matrix that is like, n-dimensional data, like numerical data, you would probably want to jump over into NumPy land and work with NumPy. Pandas is very good where there's a particular meaning to this column of data that has some label to it, like you'll see here in a moment. The size of these exoplanets or something, and that row has to be sort of respected, or that column has to be respected. And so it wouldn't make sense to transpose. Although you can transpose a data frame, if you want to, if it made more sense for you to do that. Yeah, I don't think I have transpose in here. This is just some more slicing and dicing of the data sets. Okay, so now I want to, how are we doing? Yeah. How we get into pandas, right? So I've just done all this read CSV stuff that's just kind of magical out of nowhere. But I want to show you all the different kinds of ways to read data into pandas. This is just a little setup thing. We're going to create a temporary dictionary, or a temporary directory, and throw some data in there, read it back out, and so on, just to show you how these different input and output functions work. Yeah, so here's our exoplanets, CSV. There's a lot more columns that are not shown right here. Let's see. Yeah, so this is just a range index. It goes from 0 to however many planets they found here. So now, read CSV. I want to show you this. If you learn nothing else from here, learn to love read CSV and all the different. So I know there's a lot of ugly data out there, but I promise you that if you have a CSV file, tab separated or whatever it is, it's worth a look at all these different options before you go off and say, you know what, I know my data has this weird thing to it, I'll just write a little Python code or whatever. I promise you that whatever kind of weird situation your data looks like, or how you want to sort of massage the reading in of that data, someone has probably had that problem with read CSV, and they put an argument in here to help you out with it. So in particular, what we're going to use for this data set is we're basically going to say, well, there's one column of that data that's going to be my index column, how I want to label all the rows. And in this case, the name of that column is date. And it will read this in, and then the other one, this one will get you every time with pandas, that you would think that if the text in the file says 1988-01-01, that it would say, oh, okay, here comes a date. By default, pandas will say, that is a column of strings. And so I have a string of 1988-01-01. The next string is 1988-89-01 or whatever. So you have to tell it that, use this command line argument to say, if you encounter string-like things, and there's ways to flip switches on date-like strings. If you encounter date-like strings, parse them as dates and make them into a real datetime object. So that is something that would have saved me a lot of pain in some early pandas work.
Why is date in row 1 and all the other headers are in row 0?
Right here, right?
Yes.
Yeah, so what happened there was I made date the index column, right? So the index is always going to be pushed over here on this left-hand side. And the way that, so an index can have a name associated with it. And so in this case, our index is named date. And that's right, yeah. So let's say that it was printed right here. Okay, so it would be a little bit harder to tell you that that is the index of this data frame and not another column. Okay. So it's a decision for display. I mean, it looks a little bit funny actually until you get used to it, that I have this gap here. But the general idea is to say that there's something different happening on this left-hand side. That's why it's bold too. Okay. And so what's happening is the left-hand side is the index. In this case, the index has a name associated with it, which is date, and then the rest of the columns are here. And so we can investigate that index just by typing data.index, and we see that it is of type datetime64. So it's an 8-byte datetime object. So here we go. This is the question that was that came out before about what about basically lexical sorting of an index, and so that has to be done at the time that the index is set, and because once that's set, then that label is associated with that row and for the lifetime of that, or until you do something to change it, but it won't change arbitrarily, and so the idea is that an index supports the idea of sorting. So you can actually sort the values, with the flag on. This is very much like Python sort. And then we want to set that index. Now this, again, like as I was saying before, that's going to return a copy. So we assign it back to the original value. This is a common idiom when you are returning a copy, assign it back to the original variable name, and that way you, in some sense, are not changing data. And then index into it, and you can see that it's assorted by the most recently found planets.
What if you send it to a different name, it makes a copy?
Yeah, that's a copy. Yeah.
But nothing is durable so far. Like nothing is changed permanently in the data.
We haven't persisted. We haven't written anything to disk yet. I guess if that was the question. Yeah, yeah. So we haven't. So we're about to get into writing.
Go on, sorry.
Oh yeah.
It's a bit of a sidebar comment, but just scroll up a bit.
Yeah.
Is there a way, if you wanted to see where you outputted the first 3 rows of that kind of
Yeah. Here. Yeah.
Yeah, it's a small thing, but is there a mechanism to not have it truncate wide data fields? Because I've had this issue like exactly here where you have a URL.
Yeah.
It drives me nuts. I've never found an easy way to.
Yeah, yeah. Let me go up to where we set the we set some display options here, and I think if I do this, and so that we like unset that, we should be allowed to. Oh, and it was totally fine with me setting it until I tried to display. Let me do. Okay, the other way to do that would be just pick. Yeah, yeah, yeah. So let's try that. So then, and it actually, when you do this, it's actually kind of nice because now you get the nice feature of the notebook is this scrollable behavior.
Yeah. Okay. Thank you.
Yeah. So yeah. So when I re-execute these now, these will look a little bit different because we'll go off to the side. I actually prefer to do this as well because if you really want to look at it, you want to look at it. So we've done the adding columns thing before. We haven't seen this before. If you want to kick a column out of your data frame, just del, same thing, very much like dictionaries, Python dictionaries. There's a rename feature, a rename method if you want to use that. I'm gonna skip this for interest of time. I think we have until 10:30, and so I'm gonna push on and do this file format section, and then hopefully I'm gonna jump over to the other notebook to look at some stock data before we get to the break. So let's see if I can do that. So yes, I haven't told you, we've saw like that pandas supports some plotting, just some very basic, I think I just executed, there's actually a plot method on the data frame. This is another idiom that you see in Jupyter notebooks of, okay, so I told you about the matplotlib inline magic, so it's basically about putting matplotlib plots inside the notebook. And then this plotting, but we want to have a plotting object, and so that object is going to be the pyplot object that lives inside of matplotlib. And again, there's this idiom of importing it with some kind of short name, and in this case, we use PLT. So all the different file formats. So this is some nice little Python magic that I'm not going to explain. But the thing is, when you execute it, it tells you. I showed you read CSV, but the pandas namespace has a whole bunch of different kinds of ways of reading in data. And I would very much encourage you, the first thing you should think of when you have a data set, if it can be at all thought of as a table kind of structure, is to basically say, oh, can pandas read that in? And so we're going to look at a few of these. Excel, HDF, or the typical thing that you see is HDF5 these days. If a pickle file. This is fairly new, SAS. I believe this uses the SAS7BDAT file format. If that is your world, you'll find a little bit of interoperability. That's pretty new, though. Say again?
Which data format do you see more in your?
I think Good old CSV. You know, it's portable. You know, gzip CSV or bzip CSV files. There's a lot of that going on. This is a really nice way to sip data out of a big database. Is read SQL. You know, I just need to pull a little bit out and do some analysis, and so you can connect to a SQL database.
Does that work like a Hive query?
So the question is, does pandas read SQL? Will it connect to a Hive instance? I believe the answer is no. And so there's another library that I would recommend to you called Odo, ODO, and it's sort of like it's like shape-shifting your data. And so, and it's a Star Trek reference, I don't know if you've heard of it. But the idea is, yeah, so what Odo will do is it will read from like S3 or Hive or the AWS, the AWS sort of database in the cloud. Redshift, yes, yeah. And so it has a little bit more tooling to do. And then, so basically we'll bring it in and then it will understand what we would call the data shape of that. I mean, that Hive instance, for whatever data is in there, will have a schema of some kind, which we would call like, a lot of times we call that the data shape. And so it will understand how to translate that into, you know, for example, if it's a date time column and stuff like that, it'll translate it to the appropriate thing for a pandas data frame. Yeah, Yeah, and then if so odo.readthedocs, there's a read the docs on it, but that's what I would recommend. Yeah. Okay, now where's my? There we go. Oh. Yeah, and then there's also these equivalent output methods. Yeah, more information on these. So this is my public service announcement for today, which is never, ever, ever write your own CSV reader in Python. I couldn't get really a GIF, but I wanted the star to like kind of move across the screen. But that's what we got today. Let's see, there was a little bit more I wanted to do with exoplanets. Yeah, let me do. Actually, I'm going to skip this, and I'm really so this is kind of a fun thing. Basically, what we're going to do is you go through this notebook and we take all the exoplanet CSV data frame, we write it out to an Excel file, then we read it back in. We write it out to SQLite, which is this very sort of minimal Python, SQL file-backed SQL database, SQL-ish kind of database. And then we write it out to that, then read it back in. JSON, write it out to JSON, read it back in. HDF5, this is called round tripping, if you've heard of that term, to just prove that you can take something from this format, dump it out to that, and read it back in. And there are various performance levels for all those kinds of things. But I want to get to my favorite data set that we have here, which is this beer tasting data set. So it's a little bit early, for this to have a beer, but we can talk about beer. And the general idea is they had a whole bunch of people tasting a whole bunch of different kinds of beers. They rated them on various kinds of scales, and then they had some data about the beer, like its alcohol percentage by volume, that kind of thing. So it's a really nice data set. And I mean, it's a perfect example of like, okay, I mean, what do I actually have here? Okay, well, you can pretty much figure out what's going on here. All the different things that they reviewed on, maybe some free range text of like what the reviewer had to say about it. And then you can find out sort of like the mean of the reviews, and that kind of thing. We've seen a lot of this already. I don't think we've used this before. So So data frames, you can index them with the brackets for getting out a column, but attribute, what we would call attribute style access is also valid. So, df dot, and then the name of the column, which is kind of a cool thing. This is only for getting, right? So we can't set a new, when we want to put a new column on a data frame, we use that bracket and then this, the string. This works really great for many kinds of names, but if the name of your column has a space in it, that's not going to work. So the idea is that your column name has to be a valid Python identifier, which many times it is, and it can make, I think it's a nicer style. And in general, I don't like to put spaces or various weird kinds of punctuation in my column names, anyways. Oh, yes. So this is that's a good question. So the question is, what is the return type of df.beer of beer underscore style? So the type is actually, it is a series. But when we saw that at the bottom where it said dtype equals object, this is coming from the NumPy world, where when it's dealing with strings, like a Python string, it just basically says, I sort of punt on that, and it's just some arbitrary Python object. And so if pandas can't make a datetime out of it, or a floating point value, an integer, or whatever, string data comes up as dtype object, which is the same way that it would be if you had a NumPy array of strings. It would be some kind of like fixed link, size object. And so, yeah, this is just the same thing. I wanted to do, I think I'll have enough time just to get through overriding columns. Yeah, so this is where, okay, so now that we have real strings, that these beers have names, or the style of the beer has a name, this is a very common thing. What about anything that's named this, anything that has this kind of name in it? So the column itself, or df.beer style, which is going to be a series, if it's a string type column of data, will have this .str attribute on it. And the .str gives you access to all kinds of cool things. One of which is substring, right? So now we can substring all of the values in there and just get that printed out. So that's .str and then brackets, just normal slicing. What's the length of each string? And this is the one that's really nice. Now these operations are not going to be as fast as mathematical operations, because we are actually, it has to do this lexical pattern matching on every single string. So typically what we would advise people to do, if we'll have time, I think at the very end I want to hit this concept of categoricals, but the general idea is if you have 48 kinds of beer and you have 5,000 or 50,000 data entries, and so for 50,000 data entries I have one of only 48 labels, Pilsner, IPA, etc. What you might want to do is just call that 1 through 48 and relabel that as what we would call a categorical. And so Pandas provides this mapping of Pilsner to 14, right? And then you only have to worry about 1, 6, 9, 14, which is a much faster operation. And obviously with 50,000 data points, it doesn't really matter, but something like 10 million data points, you don't want to do string operations on 10 million data points. So that's kind of nice. And so what we get back here is, again, this is a testing of a logical condition. You get back what we would call a Boolean mask for that series. So exactly the same as what you would get with like a NumPy array. Oh, yeah, so there we have that. Okay, so we're gonna hit this in more detail after the break, but the general idea is that, why is it so fancy that I have a datetime? I mean, it just looks the same, like 2009, dash 10, dash 14. I mean, it's the same. So the issue, if I would have had a string, right, it prints out the same. But what the issue is, similar to how when we had a string kind of column, we had .str, with a time or a date time column, we get this DT attribute. And this gives us the ability to get more information and actually work with the fact that it is a real date time object. So in particular, we can grab pieces of that date time out if I just want the date, right, day, month, year, or if I just want the time associated with it, or the hour, and all these different, there's just a ton of, so this is another, so instead of doing the question mark syntax, you can do help, like just with the standard Python help, and see all the different answers here. So this is another one where, this was built for financial kinds of questions where there's, okay, well, what about, what trading days, are when the markets are open, this piece of data, which quarter of the year is it associated with? All of that is built into pandas. So it knows first quarter, second quarter, third quarter, if it's a work day or not, that kind of thing. So it knows the distinction between like a Friday and a Saturday. If it's helpful for you to slice your data that way. All that kind of stuff. So here, now we're starting to see the chaining of operations. So if you just go from left to right, okay, we know that df of beer name is a series. So I'm picking out one column, and then I've got, and then I'm using in this case, it's a integer-based indexing of the values of that series. So we briefly, so now I think I showed you this one time before. We have LOC, right, for label-based indexing. We have ILok for this integer-based or positional-based indexing. And just to make your life more difficult, there's another one that's actually does have some nice uses. It's called IX. And IX is an indexer that is a total free-for-all. It supports both integer-based indexing and label-based indexing. And so I would advise, I like to write pandas code that doesn't use IX, because when the reader of my code goes and reads it, they know, because I'm using LOC or ILok, what kind of indexing I'm imposing, and what I'm saying I want to do. But it can be kind of nice if it's very convenient to, on one axis, start talking about the data in a positional way, and on the other axis, you want to talk about it in a label-based way. And so IX is your super powerful indexing object, but it's the Spider-Man principle: with great power comes great responsibility. Okay, so most of this notebook is, most of the rest of this is just really digging into LOC and ILok. And so I'm gonna let you guys, that'll just be your reference, because I really wanna make sure I hit some more of the features here. We might go back to this at the end, depending on how long it takes us to do the other exercise. But the general idea of hierarchical indexing is, we talked about, the label, this index has a label that can be a string, it can be an integer, it can be a date time. But what if it's basically a multiple dimensions to that label. So the label associated with a row is the tuple of date time, string, and integer for some reason. And so actually we look at a little bit of that with the, so this is a perfect example here. So the beer reviewers, many people, several thousand people reviewed several thousand several hundred beers, right? So that's not going to be a unique index where of beer ID. There's because so many beers were reviewed. But the combination of the person who reviewed it and the beer at a particular time indicates a specific that is a unique index into that data. And so this example kind of goes a little bit more into the details of that. Okay, I'm going to do the last thing I want to do before the break is there was the question. Oh, so here is the notion of categoricals, and so I'll just leave that for you. But the general notion is 10 million rows of data of where there's a string, the type of beer or whatever, and there's only 1,000 different categories of beer, let's say. Maybe that's too high. I don't know. There's a lot of kinds of beer. That is going to be a lot of data that is taken up in your data frame. A lot of data in memory. So the general idea is we can convert that column into a categorical, and I'll show you the syntax for that, which works like this. So beer style goes to as type category, reassign into beer style, and when we get back the information on that, this is known as a category D type now, and there are 50,000 entries, and basically the point of this is to show you that the memory consumption goes down by about a factor of 2. If you had longer strings or more data, you would see a more significant decrease in data size. But of course, that's I guess that's just that one column. So it gets a little bit harder to do some of your operations. We now deal with the same way we had for string types. We had .str. For date times, we had .dt. For categorical columns, we have .cat. And this is a little bit of detail on how that works. So so why don't we take the break now, and then we'll come back. We'll do a little bit of these what we typically call like split, apply, combine operations, or in pandas we use this group by. And then at the end of that, we'll look at how you can start your own hedge fund with pandas analysis in something we call the Turning Tuesday hypothesis. So I think we're done until right at 11 o'clock. Is that right? Okay, well so I'll be around. I'm just gonna hang out up here. Maybe if you put your hand up, I can answer any questions, and we'll start up right at 11 o'clock. We have, awesome. Now at the critical moment. 2 awesome prizes available that basically NumFOCUS is making this happen for you today. We have the 2nd edition of Guide to NumPy, which is a really nice printed updated version of the Guide to NumPy. I read the Guide to NumPy 1st edition in that limited distribution PDF format, and it was super cool in 2006. And only 9 short years later, Travis has done the 2nd edition, updated it. And so there's 2 of those. And then these are our super cool, what we're calling limited edition Continuum shirts, Anaconda shirts, show your superpowers, little kind of Marvel-inspired Anaconda shirts. So these are also available. We're going to do through a raffle. So what James is going to do is pass around. I don't know why he has a super cool bowl like that, but he does. And so put your name, email address, or business card on a piece of paper, or a business card in there. Then we're going to do a drawing. And then you for these wonderful items. So that'll be happening as I finish up here.
And the books, we can get them signed by the author?
Oh, and
He'll give you a firm handshake.
Yes, and also you can get these signed by Travis Oliphant, our founder and CEO, but also the creator of NumPy, and he can sign that and get you a signed copy. Okay, so I'm going to go through. This was a cool little piece of data exploration that I wanted to show you before I get off the stage here. It doesn't take very long to do, and it's actually somewhat interesting. So the director of finance for our company is not really so much of a Python guy, but he is a stock guy. And he told me that one day, he told me that all the traders, all the real, stock trader guys, there's this lore of this thing called turning Tuesdays. And the idea is that when the stock market is down and it's just like not going good, down for the day, these are, day traders, people who are worried about the little ebbs and flows of the market. When the market is down on let's say a Thursday or a Friday, or if it's been down for a while, it never comes back up on a Monday. Because basically people literally, because the traders are depressed and they're just like worrying about everything for the whole weekend, and they carry that worry into the next week, and so the market stays down on Monday. But then on Tuesday, for some reason, they get a little bit more optimistic, and the cooler heads prevail, and they're like, the market's been down, it's in fresh week. And so the general lore is that when markets are down, more, they turn up on Tuesday more than any other days. So I said, okay, well let us, this is this thing that traders talk about. Let's see if it's really real. And it turns out that as I was looking, to see if my friend at work was correct, there is a little bit of data to. This is just from a Wall Street Journal blog that was talking about something that was happening recently in the stock market with Tuesdays. But I wanted to get the real data. So there's a data set, it's just called table CSV in the data that you got. And it is basically daily statistics on the S&P 500. So it's the open and close, high and low, trading volume, which we're not going to use. And I think this is like related to like something about after hours or something like that. But that's the one we're gonna work with, this adjusted close column. And so now I'm just gonna blast through, using a lot of the syntax that we've seen before. And so it's ordered by day, so it goes all the way up to January 11th when I was first starting to mess around with this data. And it's daily, so this is daily data on the S&P 500 from when the S&P 500 opened, which was on January 3rd of 1950. So it's got all of that. The index, now we know, is a date time index. So we didn't get a chance to look into detail on these ways of applying functions to chunks of a data frame, but that is supported, and so I'm just going to show you a little piece of it here. But the general idea is we want to find the relative change in the market, right? So is this market a day where we ended up from where we were yesterday, or are we going down, right? So I created this little function called relative change, and let's see. Oh yes, so I'm showing you how we construct this. Basically what happens is we execute this rolling apply, we use a rolling apply, so in other words, go down the length of this column, and in this case, take chunks of 2 at a time, apply this function, and get some kind of answer out, and append that new piece of data to this data frame as a new column called up down. Were we up or were we down? And basically, that's a lot that's happening in that one line there, but that's what happens. But the issue is that what I really want to say is that, for example, January 11th is an up day from January 8th because this number is bigger than 0, but I need it to be in this slot because I'm saying that January 11th is an up day. So the idea is that I want to show you that there's this shift operation that you can do, which is very convenient to shift your values up or down. So now we have this ability to say, okay, for the up-down column, if this number is greater than 0, we know we were up. If it's less than 0, we know we were down for that day. Okay, now if turning Tuesday is a real thing, I need to start talking about Mondays, Tuesdays, Wednesdays, Thursdays, Fridays. And so that's, as I was telling you, date time index has all this, or the date time type has all of this nice capability built into it. And so if you were to look through all these different attributes, you would find this thing called daynum, day of week, which we're going to have as a column on here called daynum. So now you can see the pattern here, 0, 1, 2, 3, 4, and then there's 2 days off and a 0. So it doesn't take, it's not too hard to see that Monday is going to be 0, Tuesday is 1, and so on. So now I have the ability to say, because I care about all the things that were Tuesdays. What happened on all the Tuesdays? What happened on all the Wednesdays? What happened on all the Thursdays? What happened on all the Fridays? And so this is the grouping operation that is in more of the other notebook. So if you want to take some time, after this and go back into the first notebook, you can dig a little bit more into the group by operations. But the general idea is you're just saying group by the day of the week. And then we have this general kind of notion of split, apply, combine as a computational idiom. And so this is our splitting up, if you like, and then we do something with that data, which is we find, this is just an example of what you can do with it. You can find the mean. That's not really what we're going to do here, but that's a lot of pandas code looks like this. Grouping something and then doing some math on it. In this chained kind of way, too. That's another thing to say. Like I have a full data frame. I select out of that the things I want to operate on. I group it, and then do some math. So that's what's happening in that cell. Okay, so now I want to be a little bit more specific on what am I saying about a turning Tuesday hypothesis. So just for the sake of this analysis, we'll basically say that we're in a down market if we have 3 days in a row where we closed lower than we started, right? So we were down, so down 1 day, down the second day in a row is not considered down market for this analysis. It has to be down, down, down for 3 trading days in a row. And then what we care about is the places where we have a sequence of down, 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 and then up, right? Is it more often that happens on a Tuesday than than the other days of the week? So, so it wraps around too. So for example, Monday, what we consider about is the 2 previous, for any day, it's the 2 previous, or the 3 previous trading days. So on Monday, we care about Wednesday, Thursday, Friday, and so on. So we have a little function here that's going to calculate if the last 3 days were down. And so the way to think about these functions that get passed into apply, and actually that's actually a really interesting thing to mention, is, this is for people who come from more procedural languages like C or Fortran or something like that. What we're doing is we create a function and then we pass that in as an argument to the apply function. And we're basically saying apply to this series with a window of size 4 this function. So a chunk of our column comes in that's of size 4. And what we want to do is to say the previous day, like so yesterday's trading day, which is x of 1, and then the day before that, and then the day before that. And then it's a Boolean mask. So if all of these are less than 0, then we know that we did the last 3 days for that particular day were down. And this syntax is now deprecated, which is why it's giving me a warning. So I was just doing some sanity checking there. Okay, so now that we have this, so I basically take that answer and assign it to a column called LTDD, right? So this is last 3 days down. So now we have, for every single trading day, we have what the market closed at, whether that was an up day or a down day, based on, this is the % change for that day. We have the day of the week, and we have whether or not the last 3 days ended down. So for example, January 11th was a down day because these 3 previous trading days were down. So now the question is, okay, now I want to identify any day that was a turn, right? What we would consider. So it has the property of the last 3 days were down, right? So here I have zeros and ones, so that's my Boolean flags. I could have had a Boolean. But anyways, the last 3 days were down, and we finished up for that day. So we call that a turn day. So if that's, so I want to look at, so basically that's going to be a Boolean mask, right, or this Boolean series. And I just want to append that as another column into my data frame, and I'm going to call that turned. So, so that's what I have. So most of the time, you know, a day that was, the last 3 days were down, it was a day that ended up turning because, you know, it's kind of a rare event to have down, 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 down. But sometimes, like there's one here, yeah, where we had 4 down days in a row, right? So when we go to the next one, so this is 1, 2, 3, and then after these 3 days were down, but we finished down, so we're false, but the last 3 days were down. But then we get to this 4th day down, we have 1, 2, 3 that were down, and then we were up. So now we have everything we need to know to basically figure out this turning Tuesday hypothesis, because the idea is for all the days that were turned, what's the distribution of those days for Monday, Tuesday, Wednesday, Thursday, Friday? If there's no effect going on at all, then the turn days would be, you know, there'd be an equal distribution of Monday, Tuesday, Wednesday, Thursday, Friday. So I can already see the plots already here. But it's actually kind of amazing that for all the days in the history of the S&P 500 where this pattern happened of 3 down days and then an up day, this is the distribution. That it's very infrequent or not as frequent as the others to be a Monday. And then for some reason, people get a little bit more optimistic on a Tuesday and they turn things around. And then, you know, Wednesday, Thursday, Friday is sort of like a middle of the road kind of a thing. But so to me, when I did this, I said, well, I guess, you know, Adam is right that, now I'm not going to trust him with any of my money, like to invest anything, but, you know, but it seems that people are a little bit more depressed on a Monday and they somehow get more optimistic on a Tuesday. So here's some exercises that you know, you guys can do about, you know, that was an arbitrary pick. I said 3 days down. What about 2 days, or what about 4 days? You know, what about after you have a turning Tuesday, right? Of these 256 times when it was a turning Tuesday, is that a good day to be in the market? You know, or is it not? You know, you can sort of select out the turning Tuesday ones and then analyze from there. I'm gonna leave that and not do exercise time just to maximize more awesome tutorial time for you guys, and kind of leave that as an exercise for the reader. There were a couple questions about like what's next for pandas, or what to look at next, or you know, how does pandas fit into a world where, yeah, but I have a whole bunch of nodes, or my data is bigger than my computer, and that kind of thing. And I just want to give the encouragement to really take the time to learn the pandas and the pandas DataFrame interface, because it's been proven to be so successful and such a nice interface. I mean, it was a nice interface. It was actually stolen from R. And I was talking with an R user here earlier, and I actually wanted to know, because R language is based on S language. I don't know if S had data frames, or if the data frame notion sort of came about in the R language. I don't really know. But that was one thing I think I forgot to mention, that this concept of the data frame in pandas was basically just stolen from the R language and put into Python. But nevertheless, people have very, you know, are using a lot of it, and you know, the interface was so popular that the Spark library, you know, came up with their notion where they want to leverage this interface and this knowledge that people have gained from using data frames in a, you know, more distributed environment. And so that is the Spark DataFrame interface. In the pure Python world, I just want to mention that other libraries are out there that have been doing the same thing. And the Dask library, for example, which is a pure Python library to do distributed and out-of-core kinds of Python-based calculations where you can leverage the NumPy stack and SciPy and all those kinds of things. They also have a data structure called a DataFrame. It's a Dask DataFrame. And it attempts to emulate the interface that we've been talking about here today. So I think with that, I'm actually just going to take any last questions and then give it back over to James or allow Brian and Sarah to kind of get set up and get going, give them their full time. So is there any questions? Yeah. So, oh boy, there's a political kind of question there. Well, right. So you have many machines, right? And if you have a lot of data, you're going to benefit from having more processors to throw at it. But you are operating on the JVM, and especially if you are trying to use PySpark, you always have computation happening in the JVM, and then whatever data that needs to come out to Python for calling your Python function, there's a serialization cost of that of doing that. Then you take the results, and then they get serialized back to the JVM. So on a per node basis, you win in kind of the NumPy land. But if you were to compare one laptop running NumPy versus 60 Spark nodes, if your data is that big, it's going to win. But so that's why the desire of something like Dask is to make use of all the nice things about native speed execution with SciPy, NumPy, and things like that, and horizontally scale it out. But it's a newer library. Yeah.
Another political question. So I noticed, like in the last couple of years, a lot of these tools make it pretty easy to bring other languages inside of it. So Python allows you to do R code, or R allows you to bring in some Python libraries. With these Jupyter notebooks, have you found certain use cases where it's actually more optimal to use R for some things and Python for other things? You sort of think of it big picture, like you can actually work with both, more or less at the same time. Have you found cases where it actually is beneficial to do that, or is it really just whatever you're comfortable with, just stick with that?
So the question is, what about language interoperability and using multiple languages, and how does that work with Jupyter notebooks? Yeah. The thing that I've come across the most often is that an R user will love R, but they have a few things where they realize that, it actually would be kind of nice if I could go over into this Python land and stuff. So but there's certain statistical functions. I mean, it's just there's such a depth of stats, libraries there that you will see that sometimes they'll be like, okay, and I need to step out to R to call this little thing, and then I bring it back. That's a common thing that I see. I think you're probably going to see that, the sort of Julia Python interoperability is a story that is coming, So I'm not sure if so just so people, I think some people don't know. So Jupyter, like Jupyter, so Julia Python R, that's the renaming of the Jupyter notebook. But I think that story is going to be really interesting, the interoperability between Julia as a kind of an HPC lower level language with Python, which is very much a glue language that should allow you to talk to those things. So this is my, I guess I've got a couple more minutes, but that's my Twitter handle and that's my email address if you want to reach out to me or have any other questions or follow-ups or anything like that. But with that, I'm going to give it over to James if he wants to talk about the raffle and everything. And yeah, but I'll be around today. So thanks for listening.